Rabin Karp hash rolling functions. Let's say we have a word called Google and we want our substring or pattern. We're looking for GLE. The length is 3. Now, in order to compute the hashing functions, we have to convert to digit. Convert to digits. Since we only have 4 different characters, we have a base equal to 4 because we have G, O, L, E combination. If you are doing it generally, it will be base 26 from A to Z, and then base, the base is gonna change depends on how many letters how big your search are. So the basic formula is hash equals character times base to the power 0 plus character 1 times base to the power 1 plus character 2 times base to the power 2, depends on length. In our case, it would be 3, so we just stop it here. So we will have to compare GOO, OOG, OGL, and GLE. So hash GOO equals, let's assign a value to the digit first, say 0, 1, 2, 3. So G is 0, so we have 0 times base 4 to the power 0 plus O, we have 1, so 1 times 4 to the power 1 plus 1 times 4 to the power 2, so equals 4 squared 16 plus 4 20. So GO is 20, and hash OOG will be 1 times 4 to the power 0 plus 1 times 4 to the power 1 plus 0 times 4 to the power 2. So this case would be 5. Hashing OGL will be equal to 1 times 4 to the power 0 plus 0 times 4 to the power 1 plus 2 times 4 to the power 2. So 16 is 32, 32 plus 0 plus 1, 33, and the last one, hash GLE is equals, G is 0, so plus L is 2 times 4 to the power 1 plus E is 3 times 4 to the power 2. So we will have 0 plus 8 plus 16 16 times 3, 48. And then we would have 56. Now, in order to take advantage of the rolling hash algorithm, in this case, which means we have GOO to OOG, which means these two values are actually the same, and we can use it by doing transformation. It will be GOO minus G and then plus G, right? Plus this G, but the position is different, which means they have a different base power. So in order to do that, we have to minus the old character, which is base 0, and then plus new character, which is in this case base 2, because 0, 1, 2 we have length of 3, so just remember length is equal to 3. Our pattern is 3 in this case. We are looking for the GLE thing, so let's use the value of OGL. OGL is 33. And to do GLE, it will be 33 minus O, which is 1. Yes, just 1 here. And then plus E to the base 2, so 3. Let's speak it. Times base 0 plus 2 times base 2. Now the base is 4 because we only have 4 characters. So 33 minus 4 plus 16, 32. So become 29 plus 32 equals 61. Probably mess something up. So O is 1. Yes. So we actually minus 1 here. That's why. So we have to 32, 32. Become 64. Let's see if we make a mistake here. It's 4 to the power 1, so this will be 8. 4 to the power 2 is 16. 16 times 3 is 18, and then 48. 8, 56. That's true. No, it is different. Interesting. So we should use OGL. well, -1 plus, oh, because we forget the steps. We have to divide by base. Therefore, here, from 2 times 4 to the power 1 plus 3 times 4 to the power square be divided by base 2 times 4 to the power 0 plus 3 times 4 to the power 1. And we can times new 4 to the power 2. Over base. So this will be 32 over 4 plus 60. Wait, E is 3, so actually 3 times 16, so equal to 56, which will be the same result of the rolling hash function. So rolling hash equivalent to hash. And usage. Can be used in plagiarism and bioinformation searchings. So let's do a quick reviews. Well, imagine you have 5 even length of 10. There will be redundant calculations if we compute hash every single time. Inside we can use rolling hash to reduce the amount of calculations. Which is again rolling hash equals to old hash value minus the first character, the previous first character. Let's call it like the deleted character divided by base, and then add the new character. Of base to the power length and we can use it for DNA searches, and plagiarism, plagiarism, and etc. So let's see how the coding works. So we're gonna use vector string map.h for the power, map for the string matching to integer array, and then another map for storing for counting repeations and whether it was repeated in the searches already or not. So first we have vector string result, and then we check for bounds. If size of the string is less than 10, turn empty. And then we have default length of the pattern in the given cases would be 10. And then we have base variables. Base is 4. Which is A, C, G, T, D, N, A, S, A, C, G, T, 4 letters. Now we want to convert a string to array of integers. The strip map character to int, write DNA. So we have DNA character A set to 0. C set to 1, B set to 2, T set to 3. Now we want to initialize our array integer as array as the size of the string, and then for loop for integer I0 I less than as the size plus string array position I is equals to DNA of S at I. Now then we want to compute the first hash, put it in the hash map. Hash value initialized to 0, unordered map, integer. So let's say the first value would be our hash value, second one count number of count the number of repeats appearance. Console int go pattern for int I is 0, I less than length I plus well, we're gonna look for the first added. Calculate hash values, hash times base plus I. Now we do it reversely here because for the way our hash function works in coding, doing backwards, but essentially achieved the same results. So we don't so new values with base 0, O value with max base to the power of 10 length. And then we have to add that to the hash table. So add that to the map, pattern hash is 1. Now we compute the rest from I equals 1 to n minus length is 1. Integer base to length power base to length. We'll use this as we computing the remaining hash. Int I is from 1 to s dot size minus length plus 1 hash values equals hash times base minus I minus 1. The O value is at I minus 1 with the base 10, I mean base 4 to the power of 10, so we have to minus that. Now we get the remaining 9 numbers and we add the new numbers without dividing, because it times the base, so the base max will be plus 1, therefore we just need to minus this way. I mean, like, it's literally easier to explain in the paper. As array I plus length minus 1. These are the new value. Because length is 10, so we want to add the 10th value, so we have a minus 1. If pattern hash is equal to 1, that means repeats. We want to add it to our result vector, use pushback, which is a case of string from I. There will be 10. Length of 10, and then we have to increment hash value. Otherwise, you would be having repeated results in this in the vector you return. Then we return the vector. Try this. Run the code. Set the submit. Huh, actually it's slow again. Can submit again. So average about 80%. This is the like intuitive way to implement, so that you understand all the concepts of how the interior. Usually we just use an automap with like string that automatically translate that, but that may arise collision issues. If we use string int directly, we could have collision issues without specifying hash function. So that's it.